Welcome to this tutorial on NumPy Set Operations. Today, we're exploring set difference using the np.setdiff1d function. Set difference is a fundamental operation that helps you find elements present in one array but missing in another. This is incredibly useful for data analysis, filtering, and comparison tasks. Let's dive in and learn how to use this powerful function. Set difference is a mathematical operation that identifies unique elements from the first set that don't appear in the second set. Think of it as subtraction for sets. When you have two sets of data, set difference returns only those values that exist in the first set but are completely absent from the second set. In our example here, if we subtract the set containing 3, 4, 5, 6, and 7 from the set containing 1, 2, 3, 4, and 5, we get 1 and 2. These are the elements that exist only in the first set. The syntax for np.setdiff1d is straightforward. It takes two required parameters. The first parameter, a r1, is the input array from which you want to keep elements. The second parameter, a r2, is the array containing elements you want to exclude. The function returns a new array containing only the unique elements from a r1 that are not present in a r2. Remember, the order of arguments matters significantly. Let's look at a practical example. We import NumPy as np. We create array A containing the integers 1, 2, 3, 4, and 5. We create array B containing 3, 4, 5, 6, and 7. When we call np.setdiff1d with nb, we get an array containing 1 and 2. These are the only values from array A that don't appear in array B. Notice how 3, 4, and 5 are excluded because they exist in both arrays. One important feature of setdiff1d is how it handles duplicate values. The function automatically removes duplicates from both input arrays before computing the difference. In this example, array A contains duplicate values like 2 appearing twice and 3 appearing twice. Array B also has duplicates with 3 and 4 each appearing twice. When we compute the set difference, duplicates are eliminated, and we get a clean result containing just 1 and 2. This automatic deduplication makes setdiff1d very convenient for data cleaning tasks. Setdiff1d works with various data types, not just integers. On the left, we have an example using strings. We create an array of words containing cat, dog, and bird. The second array contains dog and fish. The set difference returns bird and cat in sorted order. On the right, we demonstrate floating point numbers. Array nums1 contains 1.5, 2.0, and 3.5. Array nums2 contains 2.0 and 4.0. The result is 1.5 and 3.5. The function works seamlessly across different comparable data types. There are three key behaviors to remember about setdiff1d. First, the function always returns a sorted result in ascending order. You cannot control the sorting, it happens automatically. Second, setdiff1d removes all duplicate values from both arrays before performing the operation. This ensures you get unique elements only. Third, and most importantly, order matters. Setdiff1d of A comma B gives you different results than setdiff1d of B comma A. The first argument determines which elements to keep. So swapping arguments changes your output completely. Let's recap what we've learned. Use np.setdiff1d to find elements in the first array that are not present in the second array. The result is always sorted and contains only unique values with no duplicates. The function works with various data types including integers, floats, strings, and any other comparable types. Finally, remember that the order of arguments is critical. Swapping the two arrays will produce different results. With these concepts mastered, you can now effectively use set difference operations in your NumPy workflows. Thanks for watching.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.